In this example, we will see how to create on-axis profiles, which are special prediction planes that are created along the axis of the speakers. To be clear, we are only modeling what happens on the axis of the speakers, and not creating a complete 3D model of the venue. The profile starts from the speaker's front rigging point and ends at the farthest point of the audience area. Several of these can be drawn, and the idea is to create a separate on-axis profile for each speaker group. For example, one for the main PA and one for the side PA, as in this tutorial. The primary purpose is to produce as accurate model as possible of the venue profile along the axis of the speaker. This is an advanced workflow designed for the most demanding conditions and requires its user to understand the three-dimensional challenges of speaker system coverage. Start by creating a new project by pressing the plus button, and give the project a name. Set the application operating mode to profiles. First, we define how many profiles are created. In this example, we create 2 profiles, main and side. The profiles have default names, but you can rename them if you want by long pressing the row. When ready, press the main profile to get to the measurement page. The profile measurement process always starts by setting the height of the measuring tool. In this example, the laser distance meter is held at a height of 1 meter. Then, stand at the front rigging point of the speaker and start measuring the on-axis profile of the venue in direction the speaker is pointing. 2 values are needed for each measuring point, distance and angle. Always take the measurements in order from front to back. Sometimes, in real-life conditions, it is not physically possible to take the measurements from the front rigging point. For such situations, the instrument has a depth and height offset parameter, which allows measurements to be taken behind or in front of the actual measuring point at different heights. When the measurements are taken, select the Profile Parameter tab. Our profile for the main PA should be wider than the width of our speakers. Listener height can be set, and an additional back wall plane can be requested to be drawn at the back of the audience area. This extra plane can be used to support the array processing and autosplay features found in simulation programs. Define the profile starting point relative to the 0 point of the simulation software. In practice, the depth value is equal to the depth of the main PA in the simulation program. When the profile is ready, go back to the project page. Next, we measure the profile for the side PA. Repeat the measurement process for the side PA. When the measurements are taken, select the Profile Parameter tab. The starting point for the side PA is set little differently compared to the main PA. The depth, width, and horizontal rotation angle values are basically the same as the position of the speakers in your simulation software. Side PA is identical on the other side, so we want to use the mirror function. When the profile is ready, go back to the project page. You can view the final result in the preview window. When you're done, press the Export button to get a file that you can import to your simulation program. You can change the output format in the program settings or by long pressing the Export button. Open the simulation software and get the prediction planes using the Import function. The application allows you to work with several simulation programs using the same workflow, but of course this also requires practice before real use. That's it. Thanks for watching this tutorial by OK Sound.